Hi, in this video we are going to talk about lasso, which is a regularization method that offers a way to estimate the coefficients of the linear regression model. Like ridge regression, it introduces a little bit bias compared to the least squares method, but can reduce the variance significantly. And it can also be used when there are more unknown parameters than data points. Unlike ridge regression, lasso also performs feature selection by setting some of the irrelevant predictors to zero. So as a reminder, we consider the linear regression model where we would like to estimate the unknown parameters beta 0 to beta p from the data y. And a classical way to estimate the coefficients is to use the least squares method. That is, we minimize the residual sum of squares. And remember now that some of the predictors in the model might be irrelevant, and we would like to set those betas to 0. So lasso, or the least absolute shrinkage and selection operator, is a regularization method that offers a way to estimate the regression coefficients. But it also allows us to do feature selection. As said, it introduces some bias compared to the least squares method, but can reduce the variance significantly, and we can use it even in a case where the p is larger than n, so when we have more unknown parameters than we have data. So lasso estimator can be found by minimizing the residual sum of squares plus an L1 penalty term. And lambda here acts as a tuning parameter, and the penalty term is small if the parameters are small. This brings again the coefficients closer to 0. And notice that we do not want to shrink the intercept beta 0, which is related to the mean of the response y. If the lambda is 0, we get the least squares fit. And when lambda tends to infinity, the coefficients tend to 0, and we get the 0 model. We can write the previous minimization model using matrix notations, and here we have assumed that lambda 0 is 0 to simplify the notations. You can also achieve this by standardizing the coefficients. One important thing to notice is that the L1 penalty term that we use here is not differentiable at 0. So unlike the ridge regression, this problem does not have a closed form solution, and so we need to solve it numerically. You can, for example, use coordinate descent to solve this problem. So let's consider an example where we want to predict the credit card debt using credit card data from 400 people. We fit the linear regression model using lasso. In the picture you can see how the estimates for the coefficient change with the different values of lambda. We start with lambda 0, which corresponds to the least square solution, and when lambda grows, the coefficients shrink towards 0. And notice that when lambda grows, the coefficients are set to exactly 0, one by one. Once a coefficient is set to 0, it will stay 0. We see that lasso can be used for feature selection. Changing the value of lambda, we can create models with any number of predictors. In the example, we start with all 10 predictors, but soon reach a model where only the predictors with 4 largest coefficients are included.